We discussed in the previous lecture about how to print data, which means how to output our data from our program. So the program has three stages: input, process, and output. So we discussed output in the previous lecture, and today we will discuss how to input data to our program. So when you input data, so you can input using many devices. Keyboard is the main input device. Then you have network, speakers, and so on and so on. But here we discuss how to input data from the keyboard. So when you type something to the input and you say a number, a text, so you want to store it. Okay, you want to store it to reuse it or use it in the future. So this is without this we don't have any usage, or we cannot use our input data, because we have to process or output, we have to store it first. So in computer memory, so we want to store them in computer memory. So the computer memory, to store it, the computer memory has bits. Okay, so if you want to insert something or store something in the computer memory, say this is our this place, so we want to give it the place, or we call it address of the memory, main memory. Okay, and then we want to give a size of the data. Okay, so in the size, depending on the size, depending on the different data, the size changes. The text size is different from one character and number, whole number, or it changes in decimal numbers as well. So you have to have different size depending on the data. And then and you have to specify the type as well, type of the data. So for example, last time we discussed the difference between decimal numbers with decimal places and whole numbers. So if you have the same size, depending on the type, the interpretation or the operations can be different. So we have to give these three, specify these three values in the when we are storing our data. So usually address is so everything is binary, so it's something like, address can be something like this. Usually it is 64-bit these days, depending on your architecture. So earlier it was 32-bit. When it was 32-bit, we had only around 4 GB memory, because different memory locations, because it's 2 to the power 32, it's around 4 GB memory we can address. But now in the present computers, we have 64 bits. So it is a very large amount of memory. So you will not, at the present scenario, we don't know. And at present, it's enough for even petabytes of memory. Okay, so the problem with this one is humans cannot remember these numbers and type these numbers in the program. So what we will do is we will use symbols for these addresses, like A, num. So you can have different symbols. Okay, there are valid symbol names. We will discuss them later. Invalid symbol names, and we can use a symbol. And then we want to give the so the address is fine now. We can have A, and then we have to give the size and the time. So usually these two are together. So that means a given type has a specific size. For example, we have whole numbers. We call it integers. Okay, so we use in C int for integer. So usually in most of the computers this is 32 bits. And then we have the other data types like float. Okay, so this is a decimal data type and the size is usually 32 bits. And then we have some other types, double. So it's also a decimal data type and its size is different. And then you have different data types, integer data types, short, long. So depending on the data type, so this one can be 64 bits usually. So this one can be 16 or 8 bits. Types. Okay, in different compilers it's different, but usually you have 32 bits for integers, 64 bits for long, and you have other variables like char with 8 bits usually. Okay, and so you can see that size and types are sticks together. So how do you create a input or location or memory location to store our data? So you can do this as something like this. Okay, so this one statement, we end this statement using semicolon, and this is the time. So what will happen in somewhere in the computer memory, we don't know, it is done by the computer operating system. We create a 32-bit location and assign the value A to this location. So we can access this or store these values. We can, here it's integer, okay, type. So we can store integer values here. Okay, we can do something like this. So you can see, you can change. So when you do this one, 24 will be stored here, and if you execute this one, okay, 2 will be stored here. So you can see the value can be changed. So we call these type of data variables because we can vary the values. So we call it variables. So integer A is a variable. Similarly, we can have other variables, double x, float y, similarly. So you can have a double x, so x will be created and 64-bit memory will be allocated, and here floating you have y and 32-bit memory will be allocated somewhere in the computer memory. So you can access these variables something like this. Okay, so you can do operations. So we will discuss them in the coming lectures using these variable types. Okay, so now we want to discuss about how to input data in C. So for output we use printf, printing formatted output, and for input we use a function called scanf. This function also included in standard stdio.h library. So you can use scanf. So we have a format for this. Okay, first we have to give the something like this. So the format. So it's a formatted input. So you have to give the format of the data, and then here you have to give the address of the memory location. So this is how you do it. So first you have to create something. So if you want to include an integer, input an integer, so first you have to create a variable integer a, and then you call the function scanf, and since it's an integer, so you have to pass the format %d and then the address. So this one, when you do this one, somewhere in the memory, you will allocate 32 bits and create this memory location, which is an integer. Okay, so now you can access this location. Okay, but what we need here is the address. We need the address of A. So A is a symbol, so it's not an address. Okay, so to get the address, so it's something like 101 or something like that, we don't know. Okay, some binary value. Okay, so to get the address, we have an operator called %. So if you say and, okay, A, so it goes to A and get the address. So this is an operator. So this and is an address operator. Okay, we can say it's an address operator, and you can use that to get the input and store it in the address or the address of A. So this is the format. So now we will see how to do it in C. Okay, let's start to program the user input. So we will first have to include our standard input-output file, and then we have to include insert the we have to create the main file. So this is the format we will be using. Then we need to insert the integer number. So first we have to create the memory for an integer, and then say we will print enter integer, and then we can do the scanf and the format, and then the address of A, and then printf again. You entered %d for format, and then have a new line character maybe, and then you have to pass A, print A. Okay, so A will be substituted for this format character. So now we will save this, and we will go to our Linux module, and we have this input.c. So gcc input.c, and output name maybe inputs. You can have any name, and then maybe we will need to have some error messages. No errors. Inputs, and it asks for enter a number. So I enter a number, so it will print the number. So to check whether this is an integer, we can print actually the type as well, but we will do some Okay, so we will run the same program and try to enter a decimal number. So to see what happens. Okay, so you can see now it takes the 22 point something, and but it print only 222. So because we read this as an integer. So now if you want to read say floating point number, and here the format is different now, it should be F, and here also the printing format is floating point because A is floating. So now we go compile it, run it, and you can now enter a number. But you can see there's an issue here. So it should print 2455.253.20, but it printed some different value because there's an error involving in this. So we will do this as double. We change the variable type here, and we will compile it. Okay, so it says we cannot get double here. So the double formatting pointer is called LF. So we have to change it to LF, and maybe here also same thing. And now we will compile. It's ran without any problem. So now we will enter the same number 3455.3532 and enter, and now you can see you don't have any errors because we have more accurate representation of double the decimal values, because we discussed decimal values are represented using exponent and matrixa for the constant. So the floating point has 32 bits and double has 64 bits. So you have more bits to represent numbers in double. So you can more accurately represent these numbers. So now I think you can create, or you can input a number and store it in your program.